Today we're going to start learning how to factor. Factoring is used to solve equations and simplify expressions. Factoring is breaking a number down or a term down into its pieces, and those pieces must multiply to the original expression. The first kind of factoring you look for is a greatest common factor. A greatest common factor is basically using the distributive property in reverse. You're undistributing. Take a look at this first distributive question. I'm taking 2 to x plus 3. 2 times x is 2x. 2 times 3 is 6. When I factor this, I'm just asking myself, hey, 2x plus 6, what do 2x and 6 have in common? What's the greatest common factor? The greatest thing that divides both. It happens to be 2. And then I think distributive property. 2 times something makes 2x. Well, that I need an x. And 2 times something makes 6. I need a 3. And this, then, is my answer. This is what I'll use to simplify expressions and solve equations. For the next one, I'm going to take 3x times x. That's how I get 3x squared. And 3x times negative 4, I get negative 12x. When I go to factor it, I'm looking at what they have in common. 3 and 12, they're both divisible by 3, and that's the greatest. X squared and x, they both have a single x in common. They both don't have two x's in common, two x's multiplied. A single x is what we got for our GCF. 3x times the first spot makes 3x squared. I need another x. Minus 3x times the second spot makes 12x, and I need 4. And this becomes my answer. This last one's a little more complex. Notice that when I take 2x cubed y squared times x to the first, x cubed becomes x to the fourth. And when I take 2x cubed y squared times y to the first, y squared becomes y cubed. When I go to factor it, I can see they have a 2 in common. That's the greatest common factor. And for the x's, I'm looking for the most they both have in common. They both have an x, they both have an x squared, they both have an x cubed. They have 3 x's multiplied in common. They both don't have 4 though. X cubed is that greatest common factor. Y squared and y cubed, they both have a single y in common. They both have y squared in common. They both don't have y cubed though. Y squared is that GCF. Then just like the previous two examples, I think distributive property. 2x cubed y squared times something makes 2x to the fourth y squared. I need another x to make x cubed x to the fourth. Minus 2x cubed y squared times something makes 2x cubed y cubed. I need another y to make y squared y cubed. If that didn't make a lot of sense, examples I think are what you need to figure this out. Let's look at the one in blue below. 8, 12, and 20, the largest number that divides all three is 4. A to the fourth, a cubed, and a squared. They all have an a. They all have a squared in common. They don't all have a cubed. So a squared is the greatest they have in common. B cubed, b squared, and b, they all have a b. They don't all have two b's multiplied in common. B is that GCF. Now I'm thinking distributive property. 4a squared b times the first spot makes 8a to the fourth b cubed. I need a 2 to make 8. I need 2 more a's, a squared, to make a to the fourth. And I need 2 b's because b to the first times b squared will make that b cubed. And then I have a minus. 4 times 3 is 12. A squared times something makes a cubed. I need another a to make a cubed. B to the first times something makes b squared. I need another b to make b squared. Plus 4 times 5 is 20. When I take 4a squared b times this term, it has two a's in it, and notice I only need 2, so I don't need any more a's. and it has a single b in it, and I don't need any more b's to make just a b. This becomes my answer. This gives you a rough idea of where we're headed with this. The thing to remember is the first thing you look for when you're factoring is a greatest common factor. It's always the first thing. If you're a little confused still, watch some of the examples. We're going to do a bunch in the upcoming slides. Question 1, 9x plus 45. The greatest common factor of 9 and 45 would be 9. And 9 times x is 9x, and 9 times 5 is 45. The greatest common factor of 15x and 20, the greatest number that divides both is 5. And 5 times 3x is 15x, and 5 times 4 is 20. The greatest common factor of x squared and 3x, notice how they both have an x in them? They don't both have two x's multiplied in common, just a single x. X is my GCF. There is no number in common. X times x is x squared, and x times minus 3 is minus 3x. 5x squared and 5x both have a 5 in common, and they both have a single x in common. 5x is that GCF. 5x times the first spot makes 5x squared. I need another x to make x squared. And 5x times the second spot makes 5x. I need a 1 because 5x times 1 is 5x. More GCF. X squared and 4x both have an x in common. X times the first spot makes x squared. X times x is x squared. And x times the second spot makes negative 4x. I need a negative 4. 3x squared and 12x both have a 3 in common. They're both divisible by 3. That's the greatest. And they both have a single x. Think distributive property. 3x times x is 3x squared. And 3x times 4 is 12x. This next one, notice how they both have a negative in them. When every term is negative, it's very common to include that negative as part of the greatest common factor. Both 7 and 14 are divisible by 7. I'm going to pull out the negative because they're both negative, and they both have a 7 in them, and they both have an x in them. Now, when you pull a negative out, that means both terms inside are going to be positive. Negative 7x times something makes negative 7x squared. I need another x. Notice it's positive. Negative 7 times that second spot makes negative 14x, and that's going to be positive 2. Negative 7x times x is negative 7x squared, and negative 7x times positive 2 is negative 14x. For our last one here, they both have a 3 in common, and they both have an x. 3x times the first spot makes 3x squared. I need another x. 3x times the second spot makes negative 9x, and that's minus 3. Sometimes greatest common factors can have more than one variable. In this case, though, both terms have an m, and both are divisible by 5. So 5m is that GCF. 5n times the first spot makes 25mn. I need a 5 and an n. Minus 5m times something is 5m. I need a 1. You have to have the 1. There's your answer. 18y to the 9th plus 3y to the 5th. Both are divisible by 3. They both have a y in them. They both have 2, and they both have 3, and they both have 4, and they both have 5, but they don't both have 6. Y to the 5th is what they have in common. 3y to the 5th times the first spot makes 18y to the 9th. I need a 6 and 4 more y's, plus 3y to the 5th times something is 3y to the 5th. You must have that 1, or it won't distribute and be an equivalent expression. Question 8. 12x squared, 6x, and 15. There are three terms here, and when I look for a GCF, I'm looking for it in all three terms. 12, 6, and 15 are all divisible by 3, so that's the greatest common factor. 3 times something makes 12x squared, well, that'd be 4x squared. 3 times something makes 6x, well, that'd be 2x. And 3 times 5 makes 15. And there's your answer. Number 10, 40, 35, and 20 are all divisible by 5. That's your GCF. Remember, I want the most number of x's they all have. Every one of them has to have that number of x's. We have 20, 12, and 10. The greatest number in common then is 10. They all have 10. They don't all have 11 or 12. 5x to the 10th then is my GCF. And that times the first spot makes the first term. I need an 8 to make 40. And I need 10 more x's to make 20. Remember, when you multiply, you add your powers. And 10 plus 10 is 20. 5x to the 10th times the second spot makes 35x to the 12th. I need a 7 to make 35, 5 times 7, and I need 2 more x's to make 12, plus 5x to the 10th times 4 makes 20, and I don't need any more x's because when I take 5x to the 10th times 4, I get 20x to the 10th. Here we have two variables. Again, we're looking for the most they have in common. They all have to have it. 21, 15, and 3, they're all divisible by 3. Here we have 3 C's, 5 C's, and 4. The most they have in common is 3. They don't all have 4. D to the 6th, D, and D to the 7th. They all have a D. They don't all have D squared in them because we only have a D right here. So D is part of that GCF. 3C cubed D times the first spot makes the first term. I need a 7. I don't need any more C's because I got a C cubed here and here. I need 5 more D's though, because this is D to the first, and D to the first times D to the fifth makes D to the sixth. Clean that up a bit. I've got a plus 3C cubed D to the first times the second spot makes 15 C to the fifth D. I need a 5. I need 2 more C's to make C to the fifth. And I don't need any more D's because here I have a D to the first and there I have a D to the first. Plus 3C cubed D to the first times the third spot makes this third term. I need a 1, and you don't need to put the 1, of course. C cubed times C makes C to the fourth, and D to the first times D to the sixth makes D to the seventh. We don't need the 1. And there's my answer. This last one's a little weird, and the reason I'm giving you this question is because it leads to something we're going to learn in a few days, maybe next week. We can learn to see that there's a GCF here, and it's just a funny looking GCF. Do you see how this is in both terms? Think of this like 3xa minus 9a, where that a is 7x plus 6y. See, they both have an a in them. You could pull that a out, and a times the first spot would make 3xa, that'd be 3x. And a times the second spot would make negative 9a, that's negative 9. That's exactly what you're going to do here. See, there are two terms. There's the minus that separates the two terms, and both terms have this 7x plus 6y in common. You need to learn to see that as a single thing, like an a that you're pulling out. You're going to pull it out front. You're pulling it out of both terms, 7x plus 6y. When you pull it out of the first term, that one's gone, and I'm left with 3x. And when you pull it out of the second term, it'll be gone, and I'm left with a negative 9. Now that's kind of strange, but really understand that it's this times 3x makes this first term, and this times negative 9 makes that second term. And this is your answer. Question 16 is like the last, and I did one more because this is a little weird. It takes some getting used to. Learn to see that like a single thing. There are two terms separated by addition. They both have 8x minus 2y in them. If I pull it out of the first term, I'll be left with 3x, plus, if I pull it out of the second term, I'll be left with 5. And if I were to re-multiply, it would be this times 3x makes the first term, and this times 5 makes the second term. And that is your answer.